we got our Poland Spring. Well, Poland Spring. Official's not the official sponsor of this video. Love it. Welcome. We're going to do some scaling, right? We're going to scale today for our MCAS review. Another day, another sleigh. I don't teach ELA, but period. Welcome. Please pause the video if you need to, but going over our scaling notes, our independent variable is always going to be our scaled amount. Our dependent variable is always going to be our actual amount. The reason why is because our actual amount is going to depend on our plan. So we're going to have to scale it and then create our actual. And so our actual amount is our dependent variable. What that means is when we have our scale factor, right? When our independent variable is 1, it's our unit rate, aka our scale factor, also known as R or K. And this has been consistent all throughout 7th grade where we have unit rates and so forth. So let's go right into these examples. Also, I was going to say also, but I'm making chicken nuggets right now. Ask me later how they are. Put in the comments. I'll let you know. I'm sure they're going to be bomb. But going on here, we need to figure out, first off, we have a scale factor, which we don't really know yet, but we're given kind of this scale, right? What we were told is that for a 1/2 inch, it's 50 miles. And so here, this is our scaled per our actual. And so what we end up seeing is that it's our independent variable per our dependent variable. And so we're just adding new terms to this concept of independent variable and dependent variable. And so here we're saying the distance on the map from Clarksville to Jacksonville is 2 inches. What is the actual distance? And so we have a 1/2 inch here to 50 miles. And what we were told is that from Clarksville to Jacksonville is 2 inches. What we want to figure out is what is x going to be. There's two ways. We can do a proportion here. So here, remember, it's dependent variable over independent variable. So we can set this up as 50 over 1/2 is equal to x over 2. And so we have two fractions separated by an equal sign, so we can cross multiply. And so 1/2 times x is 1/2 x is equal to 50 times 2, which is just going to be 100. And so to get x by itself, we divide both sides by 1/2. And we end up getting 100 divided by 1/2, which, remember, this is our dividend. This is our divisor. And so this is 100 divided by 1/2. So keep, change, flip, so 2 over 1. This just means x is equal to 200. And so that means our answer is D. You could have also seen that 1/2 times what is 2? Well, 1/2 times 4 gives us 2, which means 50 times 4 gives us 200. So that's another way we could have got this one. All right, let's go into our next problem. A scale drawing of a rectangular parking lot is shown. The width of the parking lot is shorter than the length. And so what we can see is 3 2/10 is shorter than 12 8/10 centimeters. So interestingly enough, this is our width. This is our length. Think of it as looking at it like this, right? That might be where it kind of makes somewhat more sense maybe, but regardless, good news, oven's preheated, but I put the chicken nuggets in. But let's do this before we get into that. So how many feet of the parking lot are represented by 1 centimeter? This is actually asking for our scale factor. So this wants to know our scale factor. And so what we got to remember is our scale factor is when our independent variable is 1, just like a unit rate. And so we do our independent variable per our dependent variable, which just means our scaled per our actual. And so our scaled amount was this 3 into centimeters. And so 3 into centimeters What was the actual? Well, the actual size of the parking lot was 48 feet. And so to get our scale factor, remember, right? Unit rate or constant proportionality is dependent variable divided by independent variable. It's the same case here. Our scale factor is equal to our actual over our scaled. Why? Because our actual is our dependent variable and our scaled is our independent variable. And so this means I need to do to get my scale factor, maybe I'll label that as R, is equal to 48 divided by 3 and 2/10. And so now I need to remember that the 48 is my dividend because it's my numerator. 3 and 2/10 is my divisor. And so if I was to set this up maybe up here, I have 48 that goes inside my division symbol, and then 3 and 2/10 goes on the outside. What we need to remember is when our divisor is a decimal and we need to make it a whole number. So 3 and 2/10 terminates in the tenths place. That means we multiply it by 10. And so that becomes 32. And if I multiply my divisor by 10, I need to multiply my dividend by 10. And so that means I need to move the place value over to the right one time. And so this becomes 480. So I can rewrite this as 480 divided by 32. 32 goes into 4 0 times, but 32 can go into 48 one time. Now this is getting tight. This is when you guys do your crunch math. You know what I'm saying? I'm not teaching you how to divide, so that's fine. So 8 minus 2 is 6. 4 minus 1. 4 minus 3 is 1. You can bring down the 0. 32 goes in 160. Well, let's estimate. I know 30 can go in 155 times. So 5 times 30 is 150. 5 times 2 is 10. 150 plus 10 is 160. So it's actually just 5. So that just means that this goes in 15 times. So that means that our scale factor is just 15. So this means that 1 centimeter is equal to 15 feet. Bam, let me lower this down so you guys can see that. 1 centimeter is equal to 15 feet. Now, based on the scale drawing, what is the length in feet? Well, remember, we have to put our scale factor first. So scale factor, do that SF. Remember, it's scaled per actual. And this is just our independent variable and our dependent variable. So remember, dependent variable per independent variable. So this means 15 feet per 1 centimeter. Now, our scaled amount is 1 centimeter, and our actual we just got was 15 feet. And so right here is our scale factor. And so why this is our scale factor? Our unit rate is whenever our independent variable is 1. And so since our scale factor and unit rate is the same, that means that when we have 1 centimeter, our scale factor is 15 feet. So that means that it's 12 and 8 centimeters, right? And so 12 and 8 centimeters, right? And so I can just multiply this by our scale factor to go to our actual. So I can multiply this by 15. And so maybe I do that on the side. So we have 12 and 8/10 times 15. We keep track of our decimal places and our factors. There's one decimal place. I'm going to have to put that back into our product. 5 times 8 is 40. Regroup our 4. 5 times 2 is 10. Plus 4 is 14. 5 times 1 is 5. Plus 1 is 6. Now we're moving over a place value. So we need to add a placeholder because we're going over to the tens place. 1 times 8 is 8. 1 times 2 is 2. 1 times 1 is 1. We add these together. 0 plus 0 is 0. 4 plus 8 is 12. 1 plus 6 is 7. Plus 2 is 9. Bring down our 1. Then we bring down our 1. decimal place. So we move over to the left one time. This tells us that 12 and 8 centimeters is equal to 192 feet. And so that means that the actual length is 192 feet. And that was our problem. Good luck, y'all.